So now what would we like to do? So in step 4, we get to decrease the time step. Now, why would we want to do that? Kepler's law, we believe, is telling us that in equal areas, in equal time steps, you should swipe out equal areas of the ellipse. And based on what Daniela showed us, we were getting within about 1% each time. And the time step here, which is in line 11, is called dt, or delta t. So the differences in time, we have now set to 0.1. What that means is that in 1 second, it's taking 10 different steps, because 1 divided by 0.1 is 10. Now, if you make this number even smaller, we're going to get more accurate time steps. So let's try, instead of dt equals 0.1, let's try, I don't know, maybe let's try 0.05. So now we'll get twice as many time steps. So
ooh, let's see what, push plan, let's see what it does.
Okay.
Do you think it's going to take a long time for it to make an ellipse now?
Well, it certainly looks like it. And it's kind of hard to say whether that's because of our initial conditions or if it's just because of the amount of time step that's being taken.
Mm-hmm.
But I do imagine if you have to sweep out all this time, the computer has to work extra hard and be extra careful. So it does slow things down a bit. Nonetheless, let's see what these values do. Now, because I selected use mouse equals true, I can't right click on the screen anymore because that'll relaunch the object. So instead, what I'm going to do is I'm going to use my computer's built-in print screen function. And I'm going to take a screenshot, say now. And now I already have Paint open. So what I'm going to do is I'm going to paste this in Paint with Control V. And I'm going to slide the screen in a little bit. 2 copies of Daniela now, 1 frozen and 1 not frozen. And we see my area 1 and area 2. So Daniela, if you would like, I can tell you the area values.
Yes, sir.
Okay.
Area 1?
4178.07.
Okay.
And area 2 is 4123.84. And as a reminder, the delta t step here is 0.05.
Got it. How about we get another couple points?
All right.
Or data points.
Perfect. Then I'll grab one now. And we will delete the one that was in Paint and put the new one in. All right, for area 1, we have 4177.93.
All right.
And for area 2, we have 4122.16.
Got it. And how about one more?
Sounds good to me. Taking it now, we have, let's see, paste 90. Area 1, we have 4151.35.
Mm-hmm.
And for area 2, we have 4124.16.
Got it.
Right.
Shall we do one time step that's smaller?
Okay.
Just so we can see what happens to the percent error as this time step gets smaller.
I like that idea. So let's see, we tried 0.1. We just did 0.05. How about 0.01?
Getting smaller and smaller.
Take it as close to 0 as we can reasonably get. Oh, this path is fairly slow.
This seems like it might take a good while to go all the way around.
Yes.
How about we try instead, since this seems like it's going to take forever. How about if we try, I don't know, 0.03?
I like that plan. So let's change that to 0.03 because it's still quicker time steps than we did before.
Mm-hmm.
Let's start over.
Okay, that's a little better. Maybe you all at home, right? If you have a lot of patience and even more time, you can try 0.01 or make it even smaller, 0.001, and see what happens.
And we're a little short on patience, so we won't do that now. But let's take these first values. Just as before, I took a screenshot right now. Now put it into pink. Look at. The pink arrow is covering up the first number, but I do know it's 4. So area 1, we have 4112.1. And for area 2, we have 4093.69.
Okay.
Back to the code. Okay. For area 1 now, we have 4106.27. And for area 2, we have 4093.54. Let's take one last one. For area 1, we have 4123.34. And for area 2, we have 4094.45.
Got it.
Right.
So I think with these data points that we have, we should check and see if the percent error is actually decreasing, because ideally we would like it to be as close to 0 as possible.
I think that's a great idea.
Let's see if that happens.
Okay, then I will stop the screen share and I'll let you throw up your stuff. Now let's see what happens if we take a really short time step. How about something like 0.01? So if we change our delta t here, remember dt stands for delta t, to 0.01, and we start our code. Oh
man, that is quite slow.
It's at a snail's pace, but that's fine. How about we let that run for a while you do some calculations, Daniela?
You got it, Jamor.